Okay, second video of the day. So we're gonna finish this up. This one's gonna be about volumes of revolution. So we're gonna take a function, just one function, f of x equals the square root of x, and we're gonna give it a closed interval from 0 to 4. And what we're going to do is we're going to wrap this or revolve this curve around the x-axis, and we're gonna find the volume of the region that it makes. So basically what happens is, if I take f of x equals the square root of x, we have this curve right here that I've done in red. We go from 0 to 4, so I really don't care about anything past 4, so the domain is there, so I'll just look at that. So we're going to spin this around the x-axis, and what's going to happen is basically we're going to get this shape that is somewhat like a cylinder, but it's just going to be a curvy cylinder. So if I put that point down there and move that down there, basically what's going to happen if we spin this around is we're going to get something like that. That looks kind of like a cup. All right, so if you look at that, it's a three-dimensional object. All right, and it's made up of all these round objects. Okay, so if you think of this as like a cup, you think of it as spinning it around. All right, it's like a bowl, I guess, more of a bowl than a cup. So anytime we do volume of like a cylinder, our volume is equal to pi r squared times h. And there's that. And where the radius is there, and this would be the height. All right, so that's how we'd find that. Now this isn't a cylinder, but it's like a cylinder because it's round, because it's been spun around that axis. Okay, so we're going to use calculus to do this. Okay, so we're just going to make a few changes. All right, we're still going to have pi. All right. And anything with functions like this at this time in calculus, we're going to use an integral. So we're going to go the integral from where we start to where we end. So that's going to be 0 to 4. And the radius is always changing, whereas a cylinder, the radius is the same. But on this one, all right, this would be a radius here. And when you get out here, maybe that's R1, maybe that's R2, all right, R3, and maybe R4. So all of these are different radii, okay? And everywhere in between. So you got all these different radiuses. So basically what this process does is it takes a bunch of circles and stacks them on top of each other at different height, or that are all different radii, okay? So we have the pi because it's circular. Actually the 0 to 4 represents kind of the height. That's how many discs that you're going to set on top of each other to make this thing, or round objects. All right, the radius is always changing. So the radius, think of it, if we look at the top half, if we're looking here, the radius from here to here is the square root of whatever x is. The radius from here to here is the square root of whatever x is. And same thing there. So every radius is the square root of x in this case, because that's the function. So the radius is the square root of x. And since it's squared, because it's a circle, so we're using this pi r squared times h, and we're just changing it around a little bit for calculus. The pi is still there. The integral from 0 to 4 is there. This is your radius, and then we square it. So we've just manipulated the equation so that now we can solve it. So again, these would actually cancel the square root and the square, and that would become x. So you could integrate this by hand and get 1/2 x squared, plug in 4, get a number, plug in 0, get a number, and then multiply by pi. But, you know, once we learned how to do integration, we went ahead and we moved on. So let me just type this in the calculator so I can show you what it looks like if you are going to use your calculator. All right, from 0 to 4. And I have to put a parenthesis around the square root of x. I'll show you that in a second. Okay. So when you do your calculator, if you're going to type it in there, the integral, or pi times the integral from 0 to 4 of whatever the function is, and the square root of x squared dx, I hit enter. And the area, or the volume rather, of that shape would be 25.13 cubic units. So if it's in inches cubed, or centimeters, it'd be centimeters cubed. So that's how you take a function, wrap it around the x-axis, and you find the volume of what that would create. Okay, so we'll get together and talk about this here in a few minutes, but 2 videos to watch real quick this morning. Thanks.